Okay, in this video, I'm going to take a look at a way of representing positive and negative values, okay, when dealing with integers. There are a couple of methods that we need to learn. There are a few methods of doing this, but there are a couple that we need to learn for the exam. Um, and one of these methods is called sign and magnitude. And this mimics, so it mimics our way, human readable numbers. Okay, so we might write something like minus 37. So this bit is the sign, and this bit is the magnitude. So we're literally going to record that information when we write a number down. Okay, so let's have a look at an 8-bit number. Now, in most questions, they will tell you how many bits are being used for any particular representation. But in this case, I'm just using 8 bits. Right, so we've got two pieces of information to record, the size of the number and its sign. Now, in order to represent its sign, we need to dedicate one of the bits. And what we do is we use the most significant bit, the one with the biggest column heading, the one at the left-hand side of the pattern of bits, and we designate this as the sign bit. And it works really simply. If we use a 0, so a 0 means positive, and a 1 means negative. So writing down a number in sign of magnitude is no harder than writing down a normal unsigned number, apart from we use this dedicated bit called the sign bit to write down the sign of this number. So if I want to write down minus 37, what I do is I say, right, okay, first job, sign bit, let's think about that. So I say, right, sign bit, minus, that's a 1, so I'm going to put a 1. And then the remaining bits are used to store the magnitude. So just like I would for an unsigned number, so I want to represent 37, so I start with the biggest column left. So I say 64, no, I can't have any 64s, but I can have 32. That leaves me with 5 to represent, so I can't have a 16, can't have an 8, but I can have a 4, which leaves me with 1 to represent, so no 2s and a single 1. Okay, so what we end up with is two parts to our number. We have the magnitude part and we have the sign part. So this is the sign and this is the magnitude. And it's as simple as that. There is a knock-on effect. When we had unsigned, so unsigned 8 bits, the range of numbers that we could have was 0 to 255. So a reasonably large number. But with this, we've effectively reduced the range. Or we haven't reduced the range, we've reduced the size, the magnitude. So we're actually only got 7 bits to represent the size of the number. So using what we talked about in the unsigned numbers, the largest number you could represent would be if all of this was ones. And we can calculate that by just saying, oh, it's 1 less than that. 1 less than the next column, the big column. So in this case, if we've got an 8-bit number, the largest number we can represent, and it's important to say what format this is. So we're going to say S&M signed 8 bits. The biggest value we can have is plus 127. But we can have minus 127. So that is our range of numbers. Minus 127 to plus 127. So whereas with an unsigned number, you can't represent these negative numbers, well, we can. There is one weird anomaly with sign and magnitude. So let's assume I've got 8 bits again. Right, in my column headings, should have maybe put that in the clipboard so I could paste it. which I might do in a future video, but I can't bother at the minute, I have got this weird number. So it's negative. I can see it's negative because the sign bit is 1. But it is minus 0, which doesn't make any sense. So there is actually a pattern of bits that is wasted with sign of magnitude. But apart from that, it's pretty straightforward to use. It's easy to read. If you already know how to write numbers and read numbers in binary, sign of magnitude isn't much more complicated to do. You've just got to remember about the leftmost bit, the most significant, being the sign bit. And you should always start with the sign. So think about the sign first. Okay, so if I want to write down, let me just rub that out. If I want to write down the number plus, plus 250. Now, in an unsigned 8-bit value, I will be able to represent this because that's within the range, but that's too big. Now, you mustn't try and write the number down. You would have to say not possible in 8 bits. It would be possible if you added some extra bits. But it is really important that you don't attempt to write down as big a number as you can. You can't just say, oh, that's close. So you wouldn't be able to represent certain numbers. I mean, that's why we use different numbers of bits. On a modern CPU, you can manipulate natively 64-bit numbers, okay, which gives you a huge range of integers that you can represent. Okay, but with 8 bits here, the biggest is 127. The smallest you can represent is minus 127. And that's because we've nicked one of the bits. Okay. If I wanted to be able to represent up to 255 and minus 255, then I'd need an extra bit. Okay, so it's really important that you remember the range checking. So if we was to write this mathematically, for S and M signed ranges, it's going to be minus 2 to the power n minus 1 all the way up to plus 2 to the power n minus 1. Okay, which is a bit complicated to remember, but just like the trick I showed you for the unsigned numbers, all you got to do is look at the column heading. So this is your magnitude part, but you know whatever the sign bit is, so it's sign bit minus 1, so it's the all the way up to plus the sign bit minus 1. Okay, so the sign bit is 128, so it's 127. Sign bit is 128, so it's 127. So you've only got to remember that information. Okay, and that is all there is to sign numbers in sign of magnitude. Whoa.